that you have, honestly, I would just reuse the lettering I just wrote down because I know it matches. And it would be via, well, triangle YAC, congruent triangle BAC, because of angle, side, angle. So now that you have triangles that are congruent, that is when you're able to then say that the corresponding parts of them are congruent. So that's where we get our AZ is congruent to AC because of corresponding parts of the triangles. Okay? That's where that stems from. You can't just jump to that until you have shown you've got the triangles themselves congruent. Question. The fourth one. The fourth one I know is the one that most people have problems with when you're dealing with parallels. So again, let's look at make sure we set that up correctly. And as we talked about this in class, as you go through your givens, WX parallel Y Z. We mark the diagram. And then on your progression sheet, as soon as you know that you have parallel lines, immediately you want to look and see if you can find the transversal. You want to see if you can find angles. Now, when you have diagrams that look like this, you want to draw that Z. Okay? Draw the Z. Follow through. And remember the trick. The trick is where they change directions. It's where you wind up with the angles being congruent. So here we can't just say angle X or angle Z. We have to literally write out angle WXZ congruent to angle YZX. Because if two parallel lines cut by a transversal, then alternate interior angles are congruent. Okay? And then you go to your next given. Our next given on that one was WX and YZ. So I mark it. So as of right now, I have a side and an angle right next to each other. I have to find another angle before the side, or another side after the angle, or another angle after the angle. Well, what do I have? Yeah, I wrote that down. I marked it, wrote it here, and I marked it.
So what if we do like
I haven't gotten to that part yet. Did you already write down your angles? No, we don't know that. We don't know that. We have to keep going with what we know so far. So at this point, only thing that I was able to do was write down that I had those angles congruent because of the parallel. And I have my two separate givens. And like you were just saying, I can say that XZ is congruent to XZ because it is reflexive. Okay. So there, yes, you can say that, which now gives you side angle. So if you write out our triangles, triangle WXZ congruent to triangle YZX because of the side angle side. You're done. Okay. Again, what I've noticed is some people wind up doing with some of these things. Sometimes people will put together and just write all their givens down at once. But then if you do that, you'll run the risk of forgetting that you had the parallel part with the transversal. It's one of those things that does happen from time to time. Just got to be very cautious not to get out too far in front of yourself. Next one, we have a midpoint we haven't seen in a while. So let's do it. Angle K is congruent to angle M. Excuse me. And so I can draw this. So we have our angle K and angle MB congruent, so we mark them. L is the midpoint of KM. So when you have a midpoint, according to your regression sheet, it says that you go ahead and say that you have two congruent segments. Correct? So we have those two. KL congruent to ML. Definition of a midpoint. We haven't had a midpoint in a while. We always seem to be using bisector for some reason, but it's still on your sheet. And now you have an angle and a side. What else can you get from this? Yeah, exactly. Another example of using vertical angles. Angle M, LP, angle K, oops, J is vertical angles. And now you have your triangles.
This is 5, right?
Yeah, that's fine. So really, again, the only thing you had to come up with on your own was vertical angles. It's kind of nice when they're easy like that. That was my plan for this, yeah. Angle B, angle D. So you have right angles, that's given. Mark it. Since you're given that you have right angles, you don't have to state that you have them. So now you can go immediately to saying that the angles themselves are congruent. See how this is a little bit different than when it said that like AB is perpendicular to BD, you'd have to say the right angle. In this case, they're giving you the right angles right off the bat, so it's a little bit less work. So you go right into them being congruent. AE bisects BD. AE, here's BD. Yeah, it doesn't say that it bisects, it doesn't say that they bisect each other. I had a couple of people asking me about that yesterday. They were asking that if it bisects one, does it automatically bisect the other? Not necessarily. It doesn't say that it does. If it did, it would say AE and BD bisect each other. Does that make sense? Because then you can say that you have two separate ones on one side, two separate on the other, and go from there. Psst, put it away. You're not that smooth. In your pocket. Now, whenever you have a bisector, remember you always have to say whether it's a segment or an angle. Wait, what do we have again here? Angle, sine, angle. But in order to do that, I have to say that I have vertical angles. These weren't all that tough. What's that, Josh? Yeah, that's really all it is. And that's really all a proof is. A proof is a succession of steps in order that you do in a logical manner to come up with a conclusion. You know, it's like the argument of how do you make a sandwich? what do you have to do first? Exactly. Got to get the bread, right? Things like that. It's the oversimplifying of how to do a problem. And proofs are that way to just make it think in a chronological order, if that makes sense. JM bisects angle J. So JM bisects angle J. Now, how many letters do I have to use for my angles then? Got to use 3 in this case. Can't just use angle J because there's more than one of them. So we'd have to say that MJK is congruent then to angle MJL because of definition of an angle bisector. There's my 2 angles. JM perpendicular to KL. Now this case, have you noticed the difference? Bless you. Notice the difference between this problem versus ones where you had, like on number 1, where you had 2 separate perpendiculars, and this one you have 1 perpendicular. When you have just the 1 perpendicular, this is usually the case where you have to say that you have both angles that are created. That's when you go through that one, as opposed to setting them up one at a time. So angle JMK. Right off the sheet. And what's left to write out? Reflexive. Ooh, careful. That's why you gotta mark your diagram. Now, what you could do if you got overly rambunctious, because you're never rambunctious, ever. It's a joke. Sarcasm. You could have said, remember that thing we talked about a long time ago, that thing called that third angle theorem? Where if you've got 2 angles that are congruent within 2 triangles, the third angles always have to be congruent. One of the things you could have done after you got those 2 angles, you could have said that angle J is congruent to angle, angle L is congruent to angle K because of what's called, you could have said third angle theorem. And then, yes, you could have said angle side if you wanted to. But you'd have to do a whole extra step there. So then you just go through this and have these triangles. And then, see anything else? No, that's all that was. Complexity-wise, obviously, a lot of these did not have that leftover set of corresponding parts. But quite honestly, that's just one extra step on top of having to do this. So if you just remember that when you're going through proofs, if you have something that's not saying prove the specific triangle congruent, you've got to do a parts. You just have to remember that you still have to do the triangle, and just kind of do that one last step when you're done. Another thing that I know that people do tend to mess up, remember, the only way that you can show triangles are congruent is that alphabet soup stuff, that side, 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 angle, angle, side, and hypotenuse length. Okay? Those are the only 5 ways that works. Nothing else is possible. Proof-wise, when we get to the test then tomorrow, we have, the way that we wrote it up is that we wrote a couple of them that are kind of like a fill-in-the-blank type, where you have statements from the given, So if you're going through this, if you're given these kind of things, could you figure out why they were written? We have something like that. There's another one where it's like mixed together, where you might have bits and pieces mixed out, where you have to figure out why did that happen, what use, what property type of thing. And then there's one that's going to be all on your own. Right? I think it's a pretty healthy mix. The rest of the test consists really of just the algebra stuff that we throw in. You think about what we did a couple of days ago with those solving out the triangles, figuring out the angle measures, using isosceles, equilateral, things like that, drawing pictures, worrying about perimeters, side lengths, vertex angles, all that kind of little stuff. What I did was I had this worksheet that I made a long time ago. And it's kind of a mixture of algebra and a couple of drawing pictures, proof one that's sort of here. What I want to do is kind of go through a few of these with you guys so that give you time to work on it so we can all have a good old time. And I'm going to show you guys a couple of these things here. Now, right away, on this one here, before you get too far involved on it, turn over to the second page for me and cross off 6 and 8. One of the reasons why I want you to cross those off because they use systems of equations, and that's something that we did not do this year. And like I said, this is an older sheet, so I didn't readapt it. So don't worry about 6 or 8. They have a whole bunch of weird stuff that goes on. But let's walk through a few of these together. In a problem like that on number 1, what are you going to do first to figure out what x is? Yes, ma'am. Exactly. Get the 2 interior angles. Now, to get an interior angle from an exterior, what do? Yeah, there's supplementary. So the supplement to 82 would be, well, subtract that from 180, and you're left with 88. I'm sorry, supplement of 88 would be 82. Wait, is it 82 or 98? 92. 92. So you have 92 in there. What's the supplement then to 127? 53 or 43? I'm just making sure. Bless you. Now, one of the things you can do real quick here is that value of x, is that an inside angle or an outside angle? Yeah, that's one of the trick things. If you recognize it, that it's what we call an exterior angle, this outside angle is the sum of the 2 that it doesn't touch. Or you can still figure out what this is and get a supplement. Yes, sir. Yes. It's another way of doing it, because you have 3 exterior angles and 360 degrees to hit yourself around. I totally forgot about that one. But yeah, that works as well. Yep. Let's see. Let's skip ahead a little bit here. Four. Now, I like this problem, the fact that you have to remember what all those little tick marks in the angles mean. The triangle on the left-hand side is what kind? It's equilateral. One on the left, the other left. The one on the left is equilateral, which means all three sides, all three angles are already congruent, which means all three sides are congruent. Yes, sir?
So, when 6 minus 5 equals x plus 5?
And that's what I'm getting at. Because as you go through this one, then the one on the right is an isosceles triangle, which means that the tick marks follow. Okay, so it's the idea of being able to walk through a diagram in order to set things through. So you get 6x minus 5 is x plus 5. And from there, I think you guys would be okay to solve that out. That's too crazy. Yes, ma'am? How many degrees are inside of the triangle? That's how you solve it. What do all three of those angles have to add up to equal? There you go. It doesn't, they don't have to be equal. You have 2x plus x minus 10 plus 55 equals 180. Yeah, here's what we're thinking of. If I go over to number 5 is what kind of a triangle? It's isosceles. It's what we call an isosceles right triangle. If you have what's called an isosceles right triangle, that makes both of its base angles what? They're congruent. What do they both have to equal? 45. So even though you have to solve for x and y, you just solve them independently. Okay, that's the idea. Obviously 6 and 8 don't worry about, but number 7, I really like what number 7 makes you try to figure out. Take a couple of minutes and see if you can figure out how to do number 7. So let me draw this up here. Well, give everybody else a chance, please. So take a second and see if you can, in terms of what in the world is going on. As I go through this, and oops, if I'm looking at this triangle here, what kind of a triangle is that? It's isosceles. 51 is considered the what of the isosceles triangle? It's a vertex angle. So that's the vertex angle, which means that the other two angles, here and here, have to be the same. So how many degrees are in a triangle? Take your 180, subtract the 51, you get 129. Cut that in half, and you're going to get what, 64.5? Okay. So you get these base angles at 64.5. It's you have to trust the fact that it's okay. Nope. Nope. If you wound up with something that was like 64.974374443 and it was this real god-awful decimal, then you know something's really good. But if you're getting like halvesies, quarters, things like that, I wouldn't worry yourself about it. Because as we go along further and further in this stuff, you're going to see more and more fractional answers. You'll see more decimal answers. And there's nothing wrong with that. It doesn't mean you mathed wrong. All right? It's just how things happen. So you get those two base angles at 64.5. Well, the base angle at the bottom there is 90 degrees, which means if you take the 90 degrees, subtract out the 64.5, what are you left with for its complement? You have 25.5, right? So going to the next triangle over, if that's 25.5, that means that this has to be 25.5, which means that 25.5 plus 25.5 is 51, which gives you how much for Z. It's the idea that you're using complementary, supplementary stuff. I'm missing a word under 16. We're just working our way through it. When we're looking at one like this, it's the idea that you're using all the properties of things that you have been doing. It's just in a larger picture. You have to use the properties more than once. Okay? It's none of that math there was difficult. You just had to trust the fact that you were doing it right. Okay? So trust yourself. You got it. Okay. Yeah, go ahead and start working on it. I just wander around. I will suggest that as you get through like numbers 10 and 11, you obviously don't see pictures, so that might mean you need to do something. The proof on 12 is pretty straightforward. Just use your progressions and go from there. Yeah, go ahead and finish this one out. I'll collect this when you guys come in tomorrow before the test. If you're looking for other problems and things like that to look at, I would suggest just going back into the textbook itself and looking at the chapter review in chapter 4. I don't exactly remember what page that's on, but I can post that. I'll post that on the calendar for you if you're looking for other things to help review yourselves through. But one thing that I would suggest, guys, when you're looking at how do you prepare and how do you study and how do you look at proofs, go back over your quiz things. Go back over the ones we've done in class. Look at the ones we just did again today. Cover up what you have written down, especially if you were recopying what I was doing, making sure that you were getting those right. Go back and look at it as you're reading the proof. Cover it up and just say, all right, this was given, which means the next thing I have to say is that there's a definition of a perpendicular or something along those lines. That way you understand how the flow goes through. There's nothing that's going to be on here as far as proofs or anything like that concerned that is going to look anything really all that different than what we've been doing, because there's no reason to change the complexity in it as we go along. Okay. So like I said, finish out this whole thing. You got some time on. You got another 15 minutes or so, but I'll just wander around, see how you're doing. Yeah, Mike.